We're going to start the unit off for right triangles in trigonometry with Pythagorean Theorem. So this is something that you have learned in the past, so we're going to refresh in the first unit here in the first day on what Pythagorean Theorem is. So Pythagorean Theorem, you have A, B, and C used to find the missing side of a right triangle, okay? So missing side of a right triangle. Sides A and B are called the legs. So here, so sides A and B, these are the legs. The best way that I can describe this is the right angle here touches the legs. The legs make an L together, a nice 90-degree L. Then C is called the hypotenuse. And then for any right triangle, we have a squared plus b squared equals c squared. Okay, so let's go over some examples. My suggestion to you is to put your A, B, and C right into your picture. Remember, your right angle here is your A and B. The little right angle touches A and B. So we have A, B. It doesn't matter if this is A or this is B. And then we have C out here. So if we use a squared plus b squared equals c squared, we get 8 squared plus 13 squared equals x squared. So we get 64 plus 169 equals x squared. And we get 233 when we add them together equals x squared. And then this is where we're going to take, to get rid of x squared, we have to do the opposite. Opposite of squared is to take the square root. Okay, the square roots here and the squared cancels each other out. So x is equal to the square root of 233, which if you put in your calculator, you get x equals approximately 15.3. All right. So go ahead and pause and try the next one. All right. So again, let me remind you in the directions it said round to the nearest tenth if needed. X equals 34.8. So we take a look at the next one. It's the same idea, but remember you're going to plug in, that's why I said it's best to write A, B, and C in there. My A and B, my right angle here touches A and B, if that's helpful. So this one I get 7 squared plus x squared equals 9 squared. Sorry, I'm trying to make it as neat as possible here with my slate today. I have 49 plus x squared equals 81. Subtract 49 from both sides. X squared equals 32. I'm going to change colors to take the square root of both sides. So x is equal to about 5.7. All right, so you go ahead and pause and try the next one. All right, so we got x equals 23.8. Going to go ahead and keep moving here. So number 5, now number 5 is a little different. It's an isosceles triangle. Both sides are the same. Now you need a right triangle to use Pythagorean theorem. If I look at the outside triangle here, this is not a right triangle. But with this nice line here cut in half, this makes this a right triangle. So I have A, B, and C. So I can use that. A is x, B is going to be 11, because half of 22, if I split that right in the middle, because of the isosceles, and then C is 24. So x squared plus 11 squared equals 24 squared. Go ahead and solve that. All right, x equals 21.3. All right, with the next one, number 6, we're going to do this one in class together. This one has to be broken down so that you get that right triangle. So we're going to have to look at this right here and separate this right triangle off to the left and ignore all of this, bring stuff over. So we'll talk about that in class. Number 7, we'll go ahead and do right now. Number 7 looks like this is your, we have a couple things. So we have 2 right triangles here. We don't know that we can't make this assumption that this is a right angle here. We do know that this is a right angle. So I have this little triangle here and this little triangle here, which I have 2 of the 3 sides. Let's go ahead and label this A and this B. I know that A plus B is equal to X. So if I find A and B, I can go ahead and find X. So I want you to go ahead and I'll help you set up the first one. So if I have A, B, and C, so if I have A squared plus 12 squared equals 14 squared for the little triangle is what I'm looking at right here. Go ahead and solve that through. And then now I have this other triangle off to the right where I have 12 squared plus B squared equals 29 squared. All right, so I got A is 7.2 and then B is 26.4. I add them together, so which is equal to X, which is equal to 33.6. That's my final answer because I was looking for X. All right. So if I look, number 8 we're going to do in class together. Number 9, same idea as we talked about before. So if I know this is a nice trapezoid, this is 20 over here, it matches that. This 26 can come down. I'm bringing it down to the middle because it goes from here to here. So 40 minus 26, okay, is 14. Let's say that because the sides are the same, these 2 bottom pieces are the same. So if I divide by 14 by 2, I get 7 and 7. So I'm going to say that this is 7 here. So let's go ahead and find X. So I'm just looking at this piece right here. Go ahead and pause and try that out. All right, so X equals 18.7. Again, as you're working through these, if you have any questions, please bring them to class. All right, we're going to look at some application problems. It says draw a picture, then solve for the missing side. I can't stress this enough. Draw a picture. A roofer leaned a 16-foot ladder against the house. If the base of the ladder is 15 feet from the house, how high up does the ladder have to be? First of all, we're going to look at this right triangle here. Draw best right triangle I can get. Ooh. Okay, so there's my right triangle. I know it's not perfect. So if a roofer leaned a 6-foot ladder up against the house, so here's my ladder here, okay? This ladder is 16 foot. This is my house up here. So you need to add more to it, whatever, to make it to where you understand it, but here's my house. So if you lean it up against the house, the base of the ladder is 5 feet from the house. So the base of the ladder is right here. Here's the base of the ladder. And here's the house. This is 5 feet from the house. Okay? How high up on the house does the ladder reach? So we're looking for this value right here. How high up does the ladder reach the top of the house? My right angle is here because I'm going to assume that it's completely straight. The side of the house is straight with the ground. It's perpendicular. Here's my A and B, and then my C. So I get x squared plus 5 squared equals 16 squared. x squared plus 25 squared, or 25 equals 256. Subtract off 25. Square root of both sides. I hope you're using your calculator for this. So 15.2, that is not my answer though. My answer would be about 15.2 feet. Application problems, you need to have your labels in there, okay? So application problems, again, you need to have your labels. 15.2 feet. All right. Let's take a look at number 11 here. So Kurt is building a rectangular deck. First of all, I'm going to start with a rectangle. Okay, your picture doesn't have to be perfect. If the dimensions of the deck are 10 feet by 23 feet, I'm going to put 10 over here because that looks like my smaller side, by 23 feet. Okay. What is the length of the diagonal of the deck? So they want to know this length right here across the middle. Now remember, if it's a rectangle, rectangles have 90-degree angles, so there's your 90. So now I'm looking for C. Let's go ahead and pause and try that out. Okay, hopefully you get 25.1 feet. Okay, now let's go ahead and look at another one. So if Ashley jogged 3.4 miles east, then 5.7 miles south, how far is Ashley from her starting point? So let's go ahead and say that so never eat soggy Wheaties. I don't know how you learned your north-south. Your north, south, east, and west. Okay, there it is. So if I'm going to start her here, if she jogs 3.4 miles east in this direction, then she decides after 3.4 miles to go 5.7 miles south, so we're going straight down. Okay. They want to know how far is she from her starting point. So what is this distance here? Okay, and again, if she went straight east and then straight south, she's going to make a nice right turn. So this is going to be her C. Go ahead and pause and try it out. All right, so I got 6.6 miles. Number 13, we're going to do this one in class together. And that is it for your notes for the Pythagorean Theorem. We will work on the Pythagorean Theorem converse in the next video.